गुड मॉर्निंग स्टूडेंट्स। आपको मैंने इक्विलिब्रियम कांस्टेंट के बारे में बताया और ये बताया कि कितने तरह के इक्विलिब्रियम कांस्टेंट्स होते हैं, केपी एंड केसी के बारे में बताया। एंड टुडे आई एम गोइंग टू टेल यू अबाउट द रिलेशन बिटवीन केपी एंड केसी। सो लेट्स कंसिडर अ सिंपल रिएक्शन ऑफ दिस टाइप, A plus B plus C with D and E. And let me put the stoichiometry. Suppose let it be 2 and let it be 3 times of D. Okay. Now what will be the, suppose this is in solid state, okay, and this is our gaseous state, and this is also in gaseous state, and this is in gaseous state, and let this also be in our gaseous state, okay, and this one is our solid state. So when we write the equation Kc, then how we will write Kc? Kc will be equal to how much? Active masses of the products. These are our reactants and this is our products. Okay. So Kc will be equal to product of the active masses of the product first of all. So what it is? D and E. Okay, and here the stoichiometry is 3, so we will write 3 as power of D divided by the product of the active masses of the reactants. And here we can see that this is our solid state. A is in solid state, so we will ignore it because the solid state active mass concentration is taken as constant and is taken as unity. So we will consider only B and C. So what we have here is B raised to the power 2, since its stoichiometry is 2, and multiplied by C. So this will be our value of Kc. Okay. Now when we are going to calculate the value of Kp, Kp will be how much? Kp will be equal to partial pressure of only the gaseous states. Moreover, there will be a relation between Kp and Kc only if any of the reactants or the products is in gaseous state. If none of the reactant or product is in gaseous state, then there will be no relation between them because Kp will not then be defined. Okay. So Kp will be equal to how much? Partial pressure of D multiplied by partial pressure of E divided by partial pressure of B and partial pressure of C. Now we raise the stoichiometric powers. Here it is 3 and with B it is 2. Okay. So this is our representation for Kp and this will be our representation for Kc. Now we have to find the relationship between them. Okay. Now first of all, we all know that the ideal gas equation is given by Pv is equal to nRT. Here P is the pressure, V is the volume, N is the number of the moles, R is the gas constant, and T is the temperature in Kelvins. So pressure will be equal to how much? N upon V into R. Now this N upon V stands for the concentration term. So it is actually C into R. And this concentration term is same as this one. So when we write this in terms of this, then what we will do? This actually pressure is equal to how much? CRT. So in place of this partial pressure for D, we can write it as C concentration of D multiplied by RT. So what we have here is concentration of D into RT raised to the power 3, then concentration of C E, okay, into RT divided by concentration of B into RT raised to the power 2, okay, and then again concentration of C RT raised to the power 1. Okay. So what we have here is concentration of B into concentration of E RT cube and RT becomes 3 plus 1 becomes 4. We add up the power, so it will become 4. divided by CC raised to the power 2, and this was raised to the power 3. Okay. So CC RT square and 1 means RT 3 raised to the power 3 cube of RT will be here. So what now finally what we have is, we can say see this, that this is CdQCE. This is same as this thing. Okay, concentration of dq and concentration of E. Concentration of B raised to the power 2 and concentration of C. This is same as this term. Okay, so we can write here Kc. In place of these terms, we can write Kc. And here we are having RT raised to the power 4. RT raised to the power 4 divided by RT raised to the power 3. So this will come out to be RT raised to the power 4 minus RT. This should be kept in bracket. RT raised to the power 3. Okay. And this comes out to be RT because 4 minus 3 is 1. So it will be RT. So the relationship will be KP will be equal to Kc into RT raised to the power 1. Raised to the power 1. Now from where has this 1 come? This is actually the difference in the moles of the reactants and the products. Okay. This is the difference in the moles of the reactants and the products. Just have a look over here. This is 4 minus 3. What is 4? 4 is this is 4. Okay, 4 minus 3. This has come from here. This was our product moles, number of moles of the products. This has come from the number of moles of products. Just have a look at the products. Products is 3 plus 1. So it is actually the stoichiometry, the difference in the number of moles of the product of only the gaseous reactants or the products. Okay, only the gaseous entities have a say in this. So it is actually the difference in the number of moles of reactants in the products. RT, this is actually raised to the power delta of Mg we can write. And what is delta Mg? Delta Mg is number of moles of the products minus number of moles of the reactants of only the gaseous participants, okay, of only the gaseous entities in this reaction. So this is delta Mg. So our reaction, so our relation, what is the relation between Kp and Kc? So Kp is equal to Kc RT raised to the power delta Mg, where delta Mg is Np minus Nr, and what is Np? Number of moles of the product minus number of moles of the reactants. Okay. Now I would like to have some numericals for you, and before that I would like to tell you one thing about the reaction quotient. Means what is reaction quotient and how is it related to Kc? Okay, Kc and the equilibrium constant. Now let us take some examples for explaining the Kp and Kc values and the delta Mg. Okay. Now first of all, let's take the simple reaction of gaseous. Both are gaseous. NO2, NO2 and N2O4. This is twice of NO2 and N2O4. There is equilibrium between the two. And suppose we have to calculate delta Mg in this case. And first of all, let me write Kp is equal to Kc RT raised to the power delta N. Okay. So first of all, let's calculate delta Mg. So delta Mg is how much? Number of moles of the products minus number of moles of the reactants. So for first case, delta Mg value will be how much? Of the products. Products is 1 minus 2. So delta Mg will be equal to minus 1. Now let's take for the second case. For second case, its given 1 minus delta Ng will be equal to how much? 1 minus 1 plus half. When we calculate it, it will be 1 minus 3 by 2 and it comes out to be half. 2 minus minus of half. Okay, minus half. 2 minus 3 is minus of half. Now let's come to the other example of formation of NH3. It will be delta Ng will be equal to how much? 2 minus 1 plus 3, 4. That will be minus 2. And for the last relation, it will be 2 minus delta Ng will be equal to 2 minus 1 plus 1, and that comes out to be 0. So if we talk about the relationship, so for the first one, it will be Kp will be equal to, I am writing here only, it will be equal to Kc into Rt raised to the power delta Ng, and for first one, the delta Ng value is minus 1. So it will be minus 1. If the value of Kp is given or the value of Kc is given and the temperature is given, we can easily calculate the other one. And for the second relation, it is minus 1. So Kp will be equal to Kc Rt raised to the power minus half. For the third one, it's minus 2. So here Kp will be equal to Kc Rt raised to the power minus 2. And for the last one, it's 0. So here we can see that Kp will be equal to Kc, because Rt raised to the power 0 will become 1. So Kp will be equal to Kc. So we can conclude that whenever the delta Ng is 0, means there is no difference in the moles of the reactants and the products, then value of Kp will be equal to Kc when delta Ng is equal to 0. Okay, so this was very simple, and I know you all knew it very well from class 12 also. This was just for your revision. Now I will tell you another concept of reaction quotient.